Okay, let's get started with 3.3, which is properties of logarithms. That's what we're working on here. So, a couple things right away that we can deal with. We have the change of base formula. So this is the thing on the calculator where if you don't have the option to change the little number, the subscript, to your base number, okay, you can do this by doing log base 10 of x, the big number, over log base 10 of the smaller number, right? So log a of x becomes log 10 of x over log 10 of a. You can also do this using the natural log. Okay, it actually works with any log that you wanted to. As long as the base is the same, you can divide like this. All right, so let's take a look at some examples. If we wanted to change log base 4 of 25, we could do log base 10 of 25, the big number, divided by log base 10 of 4. Plug this into your calculator. You actually won't see these numbers unless you plug them in separately. But if you plug this divided by this, you get 2.3219. Same thing if we wanted to do log base 2 of 12, we could do log 12 divided by log 2, base 10s, right? Even though we don't see them, that's what the log base is. For just the regular log divide, we're going to get 3.5850. Alright, so see if you can do that on your own calculator. Do log base 5 is 16. Use this using common logs, and common logs means the regular log button, the log base 10 button. Alright? Try that. Check the answer in the back of the book and make sure you're getting the right number when you plug this into your calculator. Alright, example 2 is the exact same thing, but just to prove a point that we can do this using natural logs as well. Log 4 of 25, we get 2.32. When we did it with regular common logs, we got 2.32 as well. So it doesn't matter if you're using log base 10 or natural log, you're going to get the same thing. So go ahead and try number 7 again, but this time part B. Try this using natural logs on your calculator. Make sure you get the same number as you did using the common log base 10. Alright, so now let's take a look at some properties. We're going to learn in this chapter how to expand and contract some logarithms. And so here's the rule. If you're multiplying, we can expand this into two separate log problems using a plus. And what this is, if we think back to our properties of logs, if we have 10 to the 5th times 10 squared, we get 10 to the 5 plus 2, or 10 to the 7th. All right, that's the same thing that's happening up here. If we have log, and so on this one, our base would be 10, right? And our answers here would be the multipliers. Let me actually use smaller numbers because it's easier to write. Start over with this. Let me make these 2, how about 3? 3 to the 5th. 3 squared would turn into 3 to the 7th. Okay? And so if we rewrote this, it would be log base 3, right? And what's our answer going to be? Okay? The answer is going to be 3 to the 7th. And what's our exponents going to be here? Right? 5 plus 2. So you can see that's what's going on here. All right? So multiplying your answers means we're going to add the exponents. Okay, it works both directions. And so we can see here as well, dividing turns into subtracting. Same thing if we were doing the rules of exponents. Okay, and then the last thing here is the power property. If we have an exponent inside, we get to bring that exponent out front. All right, same thing with natural logs. These all work the same way. All right, so multiplying can expand to addition. Division can expand to subtraction, and if there's an exponent inside the log, we're going to bring it out front. 3 rules. Let's go ahead and use them. This problem says, can we split these problems up into natural log of 2 and natural log of 3? So 6 can be split up into 2 times 3. So we could break that up as the natural log of 2 plus the natural log of 3. Natural log of 2 over 27, we could change division into 2 separate logs with a subtraction in the middle. So we've got our natural log of 2, but then how do we turn 27 into 3? 3 cubed. What do we do with the little 3 here? Bring it out in front. So we'd have the natural log of 2 minus 3 times the natural log of 3. All right, so see if you can do the same thing on 27. Take 5e to the 6th and expand this thing. All right. Example 4. We're going to try these again. All right, how would we expand these and find the exact value without using a calculator? All right, so the third root of 5 is the same as 5 to 1/3. Okay, we agree with that. What can we do with the 1/3? We could bring it out front. So there's the 1/3 out in front. Log base 5 of 5 just turns into 1. 5 to the first power is 5. So 1/3 times 1 is 1/3. All right, same thinking here. Now we're going to go in reverse. Since it was a minus, but our base is the same. It's both log e and log e. We can combine it so it's division now. So we're contracting these together. E to the 6th divided by e squared. We can use our rules of exponents and subtract there and get e to the 4th. And what we have here is 4 brought out in front times 1. So we just get 4. All right, we could have gotten that kind of a faster way. We know right from the get-go, natural log and e cancel out. We've got 6. Natural log and e cancel out. We've got 2. What's 6 minus 2? You get 4. So we could try that either way on this one. See if you can do that with exercise 29. Give me an exact value. No calculators. All right, example 5. We're going to expand this. We've got some variables now, but the rules still stay the same way. This is 5 times x cubed times y. So we can expand that immediately into 3 parts. 5. The times turns into a plus of a new log, x cubed, and then times another plus over here. We're almost done, except we can clean this up here. We can take this 3, bring it out in front, and so we'd have this term right here. Same thing on the next one here. 3x minus 5 to the 1/2. Let's clean that up. We're going to deal with the division first. Turn it into 2 natural logs with a subtraction in between. We're almost done here. We can take this 1/2 and bring it out in front, and then we are done. Now don't make the mistake of thinking we can split this thing up here. 3x minus 5. We don't have a rule for how we split up adding or subtracting if it's inside. If it's adding or subtracting 2 separate natural logs, we could bring it back together, but not if it's inside the parentheses. So we've got to be done. Leave this alone. Okay, use those rules. See if you can expand problem 53. All right, now let's go the opposite direction. Let's combine them back together. So we're looking at A. Here's what the rules you want to do here. We want to first get the exponents back up, bring the coefficients back up, and then turn addition into multiplying, subtraction into division. So problem A, we'd bring the 1/2 on top, so you can see it right here, x to the 1/2. Bring the 3 on top, so we'd have x plus 1 cubed. It's a plus, so we can put it all together. Because it's the same base on the logs, log of x to the 1/2, which is just square root of x, times x plus 1 cubed. And we'd have it all as a single logarithm. Same thing here. Let's bring the 2 on top, so x plus 2 squared. The minus says let's turn this into division, x plus 2 squared over x. All right, the last one here. The 1/3 is on the outside, so we'll deal with that last after we've dealt with this. It's a plus, so we can combine them. Log base 2 of x, x plus 1. And then, since now we have a single log, now we'll bring the 1/3 and bring it all the way up to the top. And we could rewrite it using the square root, cube root symbol if we wanted to. It'd be fine if we left it just like this as well. All right, so see if you can combine this into a single quantity for problem 75. All right, last problem here. So we're going to create some logarithmic models here. And so if we have a table here, we're going to go to our graphing calculator and plug this in. So I know some of you still have trouble using the stat feature, so I'm going to walk through this all the way. So I'm going to go into stat, I'm going to hit edit, get my L1 going here, and type in 0.387, and I'll just type in all of these, 0.723, 1, 1.524, 5.203, 9.537, and now let's go do the L2. 0.241, 0.615, 1, 1.5, 881, 11.860, and 29.460. Alright, so we've got all our numbers in here. We can go and graph this real quick. Let's do our window. The smallest x is a little below that, so we could go 0, and a little above 9 is 10. Our min for the y is a little below 0.2, so 0 is good. And our max a little above 29, so we'll go 30. And make sure our plot is turned on. Don't need anything in the y's, but our plot one's turned on. And there we go, we've got our 6 points. Alright, so this doesn't really do anything for me. Is it a straight line? Is it a curve? We're not really sure. Okay? So on these problems in this chapter, so you wouldn't really know from this problem. They really should say, let's find a logarithmic model that relates natural log of y with natural log of x. And that's what the homework problems are going to say. Alright? But what we're going to do is we're going to go back into our stat. We're going to go back into edit. And we're going to create 2 new lists. What we want to do is create list 3. We want to do the natural log of all of these numbers. The natural log of 0.387. The natural log of this. The natural log of 1. Fortunately, we don't have to do that 6 times. We can go up to L3 and type in whatever formula we want to do to everything in here. So we're just going to hit natural log of L1, which if we hit second, it's right here above the 1. So natural log of L1, and boom, this is the natural log of all of these numbers. We want L4 to be all the natural logs of the second list. So natural log of L2. And so now L3 is the natural log of x, and L4 is the natural log of y. We want to graph these 2 things. And so we're going to set up our scatter plots here. If you notice here, I hit second stat plot. So I'm up in here. You'll notice that right now, plot 1 and 2 and 3 all do the same thing. They're just doing L1 and L2. Let's change our plot 2 to graph L3 and L4. Alright, so back up this video if you need to fix everything, but change it so we've got L3 and L4 in here. And at this point, we're going to go ahead and graph it. And really quickly, I'm going to jump back in here just to see what my mins and maxes. So looks like -1 to 3 and -2 to 4 would be a good window. -1 to 3, -1 to 4. And I'm going to go turn on my plot 2. Turn off plot 1, turn on plot 2. See what those look like. Look at that. That is a nice straight line. Okay? So now that we have a nice straight line, we're just going to need to come up with an equation for this line. We can go ahead and grab that from our regression. Stat, calc. We want to do a linear regression. Where am I going? Too far. Sorry. Number 4. Linear regression, ax plus b. And, oh, sorry, that's doing it off of L1 and L2. My calculator on here can't do it. On yours, if you hit linear regression, you can choose which lists you're going to do, and it'll do it right for you. I'm going to have to do it the old-fashioned way. Let's go back into the stat and look at my lists. And since I have 2 points, I could always solve this by hand. So I'm going to take, looks like 0.42 and 0.63. Just write it on here. 0.42 comma 0.63 was on our graph, so was 0, 0. Let's find our slope. So this one's going to be 0.63 minus 0 over 0.42 minus 0. If you do that, it comes out about 1.5. All right, I've already done this. So right now we have our slope. So y minus 0 equals 1.5 x minus 0. I'm just going to use this point. So we've got y equals 1.5. But remember, we didn't do the x's and y's. We did the natural logs of both of these. So that would be our final answer. All right, a lot of steps that went on there for the last one. If you think you got it, give problem 91 a shot. We're going to plug these numbers into our L1 and L2. we're going to do the natural log of x and the natural log of y and turn it into a straight line equation. All right, we'll definitely go over this problem in class, but do your best to give 91 a shot. And that's it. That's the end of 3-3.